All right, you guys, observational studies versus experiments. There's a lot of definitions, so make sure you write them down. And if you need to pause the video, just pause to write them down. I do think it helps to actually write them down. So, an observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. All right, so you're just watching what's already happened or observing data, okay? Versus an experiment where we deliberately impose some treatment on individuals to measure their responses. So you have to be maybe giving some people a drug and other people, they don't get a drug. So you're imposing a treatment, okay? So when our goal is to understand cause and effect, experiments are the only source of fully convincing data. So if you want to say that one thing caused another thing, then you have to do an experiment. A couple other definitions. Observational studies that examine existing data for a sample of individuals are called retrospective. So if you're looking in the past or at existing data, it's retrospective. If you're going to follow into the future, it is prospective, all right? All right, does taking hormones reduce heart attack risk after menopause? So should women take hormones such as estrogen after menopause when natural production of these hormones ends? In 1992, several major medical organizations said yes, women who took hormones seemed to reduce their risk of heart attack by 35% to 50%. The risk of taking hormones appeared small compared with the benefits. The evidence in favor of hormone replacement came from a number of observational studies that compared women who were taking hormones to others who were not. But the women who chose to take hormones were richer and better educated, and they also went to the doctor more often than women who did not take hormones. So because the women who took hormones did a lot of these other things to maintain their health, it's not surprising that they had fewer heart attacks. So it wasn't necessarily the hormones. So to actually get convincing data, you guys, you have to do an experiment. And if we did an experiment, we wouldn't let the women decide what they wanted to do. We would assign some of them to take a hormone replacement pill, and we would assign the other ones to take a placebo pill, and they wouldn't know which one they were taking, ideally. All right. So confounding, you guys, that's what this is called when there's really some other variable that might be causing the output. So confounding occurs when two variables are associated in such a way that their effect on a response variable cannot be distinguished from each other. I would write this one down as well. So the confounding variable in this problem, it could just be that these women were wealthier, they were better educated, so they were doing a lot of things to take care of their health. So not only were they choosing to take hormones, but they also took care of their health, and that caused fewer heart attacks. So we also want to know what a response variable and an explanatory variable are. So a response variable measures the outcome of a study. So think of it as the Y variable or the output. An explanatory variable may help explain or predict changes in the response variable. So think of the explanatory variable as the X variable or the input, all right? X variable, oops, or the input. So in the hormone study, you guys, the explanatory variable was the hormone drug that the women took. And the response variable was the percent of them who had heart attacks. So it was just the output. Sorry, my board is not working very well. All right, so in this hormone study, you guys, diet is another confounding variable. Not only is wealth, but so is diet. So this is what someone said in an AP exam, and it's not quite right. So diet is a confounding variable because people with bad diets are more likely to have heart attacks. Now that's a true statement. What they did is they tied it to the response variable, but they did not tie it to the explanatory variable. So to get full credit, you want to say that someone with a better diet might also be more likely to take hormone pills. Maybe they're worried about their health, so it's more likely they took those pills, and that diet then could have led to less heart attacks. Okay, so if you're asked to identify a possible confounding variable, be sure you, one, explain how it's associated with the explanatory variable and how it affects the response variable. So I would write that down, you guys. So anytime you're doing a confounding variable, how is it associated with the X variable? So what do they have in common? So people who took the drugs have a better diet, or people who took the drugs have more money. All right, and then how does that affect the whole heart attack issue? Well, people with more money have better health care, so maybe they have less heart attacks. Okay. So an experiment was done by medical researchers to determine the association between drinking caffeine and severity of lung cancer. Results showed that there was a high association between the two variables. Which of the following could be a potential confounding variable? All right, so we have drinking caffeine and lung cancer. So we have smoking, caffeine consumption, lung cancer, medical researchers. So caffeine consumption, you guys, that's the explanatory variable, and lung cancer is the response variable. So it's not that. All right, so which one of these is tied to both? So it has to have something in common with the X variable, and it has to somehow affect the Y variable. So obviously smoking affects the Y variable. So you would want to tie it also to the X variable. Maybe people who drink caffeine are also more likely to smoke. And the smoking can definitely cause lung cancer, or could be the cause instead of the caffeine. All right, another one, a study finds that caffeine intake has a strong negative correlation with grades for college. In other words, on average, the more caffeine intake a student has, the lower the grade the student gets. Which of the following could be a confounding variable? The amount of coffee that the student drinks. So you guys, that's the same thing as your caffeine intake, so that would be the explanatory variable. The amount of sleep that they get each night. The grade the student receives, well, that's the response variable. The amount of soda that the student consumes, that's still just caffeine, so that's your intake, caffeine intake. Here's another caffeine intake. So it has to be B, all right? And how are these tied together? Well, probably the less sleep you get, the more caffeine you have. And so it could be the fact that you have less sleep that's causing the lower grades versus the caffeine intake. All right. Does reducing screen brightness increase battery life in laptop computers? To find out, researchers obtained 30 new laptops of the same brand. They chose 15 of the computers at random and adjusted their screens to the brightest setting. The other 15 laptop screens were left in the default setting, moderate brightness. Researchers then measured how long each machine's battery lasted. Was this observational or an experiment? So you guys, did they impose a treatment? So it seems that they did choose a brightness level. So yes, it's an experiment because they imposed a treatment. All right. For the next one, does eating dinner with their families improve students' academic performance? According to an ABC News article, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. Was this an observational study or an experiment? Well, do you think that they imposed on a family and said, you guys are going to eat together 5 times a week, and you guys are going to eat together 4 times a week, and you're going to eat together once a week? All right. They didn't say that they did that in the problem, so it has to be an observational study. Okay, what are the explanatory and response variables? So explanatory is like your input, and response variable is your output. So explanatory would be the number of times that they ate with their family per week, and the response variable would be their grades or their GPA. Okay, explain clearly why such a study cannot establish cause and effect. Well, it's not an experiment. No treatment was imposed, so we don't have cause and effect. So that means that there could be a confounding variable, and you want to see if you can come up with a confounding variable that is tied to both the response variable and the explanatory. So one that they talked about is students who might have part-time jobs. So maybe they're not eating as many meals with their families, and it's actually that part-time job that's taking away their time to study, which is actually leading to lower grades. Could be a sports team that you're a part of, same thing. So you maybe don't see your family as much, and that's also taking time away from your academics. All right, a specific condition applied to the individuals in an experiment is called a treatment. If an experiment has several explanatory variables, a treatment is a combination of specific values of these variables. All right, so you're imposing a treatment and it could be a combination of different things. Experimental units is the smallest collections of individuals to which the treatments are applied. So a lot of times it's humans, and we call those subjects if it's a human, but you could be applying some sort of treatment to something else. Maybe it's a bacteria, and you're testing how to like kill it, and so your experimental units would be the bacteria, and you're imposing some sort of treatment. All right. Researchers at the University of North Carolina were concerned about the increasing dropout rate in the state's high schools, especially for low-income students. Surveys of recent dropouts revealed that many of these students had started to lose interest during middle school. They saw little connection between what they were studying in school and their future plans. So to change this perception, researchers developed a program called Career Start. And the big idea was showing the students how they actually would learn this in real life. To test the effectiveness, the researchers recruited 14 middle schools in Forsyth County to participate in an experiment. 7 of the schools, determined at random, used Career Start along with the district's standard curriculum. The other 7 schools just followed the standard curriculum. Researchers followed both groups of students for several years, collecting data on students' attendance, behavior, standardized test score, level of engagement, whether or not students graduated from high school. And at the end, the Career Start students generally had better attendance and fewer discipline problems, had higher test scores, greater engagement, blah, blah. So what are the experimental units, explanatory and response variables, and the treatments in the Career Start experiment? So the experimental units are what you're doing the study on, and so that would be the 14 middle schools. The explanatory variable, well, there's 2 of them. So one of them is the Career Start with the standard curriculum, and the other one is the standard curriculum. And the response variable is all of this data that they gathered: attendance, behavior, test scores, engagement, whether or not they graduated. So guys, that's just a bunch of definitions that you need to memorize and work on. This is super important. Experiments can give good evidence for causation, all right? And as long as you have random assignment of that treatment, it gives us cause and effect, all right? So if you randomly assign a treatment, then it's an experiment, and that also means we can conclude something at the end. Explanatory variables in an experiment are also called factors. You might see that on your crossword puzzle at the end, but any type of variable, explanatory variable, is also called a factor. And they could also have different levels. So many experiments study the joint effect of several factors. In such an experiment, each treatment is formed by combining a specific value, often called a level of each factor. So maybe you're heating something up in the oven, and you're doing some of them at 200 and some of them at 300 and some of them at 400, so there's a different level for however much heat you're applying. All right, what are the effects of repeated exposure to an advertising message? It's what we're getting all the time on our phones, we're being advertised to. So the answer may depend on both the length of the ad and how often it is repeated. An experiment investigated this question using 120 undergraduate students who volunteered to participate. All subjects viewed a 40-minute television program that included ads for a digital camera. Some students saw a 30-second commercial, others saw a 90-second, and then they either saw it 1, 3, or 5 times. After viewing, all the subjects answered questions about their recall of the ad and their attitude towards the camera and their intention to purchase it. So, for this study, identify the experimental units or subjects, the explanatory and response variables, and the treatments. So ask yourself, what are the experimental units or subjects? Hopefully you said the 120 undergraduate. All right, the explanatory variable, well, there's all the combinations. So they either saw a 30-second or a 90-second commercial, and they either saw it 1, 3, or 5 times. So that means you saw a 30-second commercial 1 time, or a 30-second commercial 3 times, or a 30-second commercial 5 times, or a 91 1 time, or a 91 3 times, or a 91 5 times. So there's 6 different explanatory variables. All right. And then the response variable, there's a couple things. Their recall of the ad and their attitude towards the camera, and whether or not they want to buy it. All right. And the treatments, you guys, that's actually all the different combinations are the treatments. I guess for explanatory, you would just say they either saw the 30-second or the 90-second and how many times. But the treatments are all the combinations. Okay. And here is your homework for Friday. I hope you guys have a great weekend. Make sure you do 4.2 worksheet from your packet and get that uploaded. And I will see you guys next week.